Hi guys, welcome back. Now we are going to take a look at GAP, which is basically generic access profile in BLE, Bluetooth Low Energy. Previously we have done some of the coding, and now we need to understand some important concepts before we do the next part of the programming, which is basically connected with the GAP, which is a generic access profile. So first, we are going to learn some basics. I have already told some basics in the introduction video as well. But here we will go a little deeper and we will see what are the things that are present in GAP, which is generic access profile. So let's start. So what is GAP itself? The GAP layer basically it's responsible for the connection functionality. It also handles the access modes and procedures of the device, including the discovery, link establishment, link termination, and initiation of security features and device configuration. Basically, whatever we are doing on BLE, we are connecting with other devices in BLE. So we have some special procedures for connection, disconnection. We have to follow some of the rules for our device in order for our device to communicate with the other devices. For example, if our device is a peripheral device and we have to connect it with the master device, we will also send it some extra information so device is able to connect so that the master device is able to connect with our peripheral device in a proper manner. For example, sometimes we need long intervals between each connection parameter update. Sometimes we will update the connection parameters as soon as possible. There are lots of stuff going on behind the scenes, so we will cover them one by one. So right now here, let's see, there are two things that are specific in the GAP, which are modes and procedures. The modes are basically the description or the working state of the device. So for example, a device might be in a device can be in different modes. For example, a device, if it's a peripheral, it can be in broadcasting mode. If a device is a master device, then it can be in scanning mode. So it depends. So what types of modes are there, it depends on that. And the procedures are basically the descriptions of the specific operation within a limited time. So for example, I have already told about some connection parameters update rules. For example, we have different connection parameters update rules. We will see them in the coding as well. So first, there are some roles, as we have previously seen in the introduction video as well. There are 4 basic roles. The first one is broadcaster, the second one is observer, third is central, and fourth is peripheral. The broadcaster and observer are basically the devices which can transmit some advertising data, and they cannot be connected. The broadcaster is basically advertising its data, and the observer is basically receiving the data. But they cannot connect. It's just receiving some type of advertisement packet, and in the advertisement packet it can receive some information regarding the device or some extra information. The main thing that we will be doing in our BLE code would be related to mostly the peripheral and central devices. So first of all, we will just go through the peripheral coding. For central, we will see it later on. First, we have to master how the BLE works, so we have to see it from the peripheral side, and mostly our equipments are always peripheral and not the master. So it's important to master the peripheral side of the BLE. Sometimes we have a different way to communicate. So in some special cases, we will also be using the peripheral, master, and peripheral, and so on, and they will be connecting with the one main master as well. So we have different ways to connect, and we will see them in later tutorials. So for now, we know that the central device is basically the device which will be connecting with the peripheral device, and the peripheral is the slave device, and it is going to advertise its data and can connect with the masters. So these two roles are important in the GAP, generic access profile, and the generic access profile basically defines the device information. For example, what's the device name and all the stuff. So it's really important in BLE. So where GAP is involved, so basically in the physical layer, when we are transmitting or receiving, in the link layer when we are broadcasting or our device is in scanning state or other states, and then in broadcast events, also in scan types, for example the passive scanning or active scanning, and also link layer control procedures which are related to connection update procedures, encryption procedures, or the termination procedures, etc. And these are all the places where the GAP is involved. So in GAP we also define the security for our services. For example, our service has some data for heart rate or other stuff. If we want our heart rate data to be encrypted, or we want our data to be secured, then we will put our device in some some security modes. So here are some of the security modes. Security mode, we have two safe modes. Basically the safe mode 1 defines 4 security modes, and safe mode 2 defines 2 modes. In the first mode there is no security, so mostly for basic data, for example if we are taking some temperature, we don't need to secure it, so it's not necessary to use some security procedures. And for most of the devices you don't need to provide some security to the service. But if you want to provide the security to services, then you can follow any of these encryption methods to secure your data over BLE. And there is a safe mode 2. In safe mode 2 we also have two types: unauthenticated pairing with data signature and authenticated pairing with data signature. So we have different modes of security in GAP, and they are really helpful if you want to secure your service data. For example, for heart rate service, if you don't want any other device to read this data, and just the device which is being connected with your device, then you can follow on these security safe modes. The GAP service is composed of the following features. So the first feature here is the device name, and device name is basically UTF-8 encoded, and it's basically a simple string. And here we will give our device name. For example, I am giving my device name as SamBT or some other name, and you can also use some special features to set the device name to be hidden from the other devices. So for example, you can set your device name to be discoverable or not discoverable by other devices based on the security. So for example, if you want your device name to be discovered by others, then they have to follow some authentication security procedures before they see your device name. And for device name we have a specific UUID which is 0x2A00, and we have our device name, and the function that we mostly use for the device name setting is SDBLE GAP device name set. And the second feature is the appearance characteristics. Only one appearance can be defined for one device. For example, if your device is an HID or a mouse or a keyboard, then you have to define its appearance in the GAP service, and this appearance will be available. This appearance can be seen by the master device, and it can recognize if it's a heart rate device or a keyboard or a mouse or anything else. There is a special list of predefined appearance for BLE by the SIG group. So we will see that as well after we finish this coding. And in the appearance, if you don't want to define your device for the standard appearances, then you can just define it as 0x00, which will say that your device is an unknown type of device. The next thing, which is really important in some special cases, is the PPCP, which is peripheral preferred connection parameters. And here we will also program this, and these are the special connection parameters that are really important in some cases. For example, sometimes our master device is not as fast as the connection speed that we want, because maybe master device might be busy in doing other stuff, so it won't be able to follow some of the connection timings. So for that we use PPCP, so our device can update the parameter connections as according to the master device. So master device will define, so our slave device will send these connection parameters, and if the master device is able to allow them, then it's going to allow them. Otherwise, if the master device is not able to allow them, then it will select the minimum or least part of the connection parameters. And if it's totally unable to accept all the connection parameters, then we will receive an error. And upon receiving that error, we can perform some other stuff, like we can disconnect from the device, or we can do other stuff. The central device address resolution feature is used to improve the security in BLE, and the central address resolution is used to define whether the device supports address resolution privacy or not. So basically what central device address resolution is, it can be authenticated. If we want to authenticate our address, so we can authenticate it, or if we don't want to, if we don't need too much security for our device, then we don't need to secure the central device address resolution. So our resolvable private address is to prevent malicious third party from tracking a Bluetooth device. And basically the resolvable private address is resolvable using a key shared with a trusted device. So the address is originally generated using the IRK and a random number. IRK is the identity resolving key. So we will see all of this stuff later in the coding. Maybe I will not cover everything here. We will see this in security features. Just now we will see the basic code to create our basic application for BLE. So here are the peripheral preferred connection parameters, and here we have 4 parameters that we will be setting in the GAP function. So we need to understand these parameters. So the first parameter is minimum connection interval. So the minimum connection interval is between 7.5 milliseconds to 4 seconds, and it's a connection interval. So there is a special event which is called a connection interval, and in this event basically the master device will send this event to the slave device, and the slave device will respond it back saying that I'm still here. So basically after we set this time so that our connection is maintained with the slave device. So we have 2 parameters. The first one is minimum and the second one is maximum connection interval. So we can set it between 7.5 to 4 seconds. So for example, if it's set to 7.5 milliseconds, then after every 7.5 milliseconds the peripheral device will receive this connection event, and in this event the peripheral device has to respond back that I'm still here, so that the connection then the master knows that the peripheral device is still there and it's in the connected state. It remains in the connected state. But if the connection interval after this connection interval the peripheral device do not respond, then the master device will consider the connection has been terminated. So Now we have two parameters, so it also depends on the master device as well. So for example, sometimes the master device is too busy with its work, so it won't be able to accept 7.5 milliseconds. Maybe it can accept 100 milliseconds or 200 milliseconds. It depends on the connection interval. It also uses a lot of battery because we are continuously checking whether our device is connected or not. So for this we have a specific time here, and the more time we give between the connection intervals would make your device more energy efficient, and the less time you give, the less energy efficient your device becomes. The second thing is the slave delay. The slave delay is basically another feature of BLE which helps our device to save some more energy. So for example, it's basically the number of times the slave skips this connection interval event. So basically, when a master device sends a connection interval after 7.5 milliseconds, our slave device can skip this event for one time or two time or three time, depends on our settings. So once it skips this connection interval event after two times or three times, then after on the fourth time it's going to respond. It depends on our settings. So by this way we can let our slave device or the peripheral device to stay in a sleep mode and consume less energy as possible. So this is another way to help reduce the battery consumption. And the last one is the supervision timeout. The supervision timeout is basically the timeout between two successful connection events. So it's between 100 milliseconds to 32 seconds. And for example, if the connection event hasn't occurred during in this window, for example, if I have set it to 200 milliseconds and our device here we have set it to 100 milliseconds, and the times it can skip can be 1 interval or 0 interval. So for example, it doesn't skip any. So after two connection events, there is still no response, then the device is going to come back to a disconnected state, and the connection will be lost. So by this way we control the connection with the device, the master and the slave device. So these are the basics of PPCP, and we will now see their programming. And for programming we just define these constants, and then we will pass them to the GAP function, the GAP initialization function. So in that function we will do all the stuff. So that's it for this. Now let's start coding, and we will see in the coding we will see what functions are available, and how we are going to use these functions, and how we set it up so that our generic access profile is available to the master device. So the master device can see in the master device we can see what is the name of our device and what are the connection parameter updates, and either the device address resolution is supported or not, and is it resolvable or not, and what is the appearance characteristic of our device. So let's see in the coding. So guys, now let's start programming, and the first thing we need to do is we have to create some of the constants for our device, for example for our device name and the preferred connection parameters. So we will define them now here. So let's start. The second one is a minimum connection interval, and here we use a special function which is going to convert the milliseconds from our specific units here, because we are using RTC, which is the real-time counter, and it is basically connected with a low frequency clock, and the minimum unit of time it can give is 1.25 milliseconds, because it's configured in that way. So now we are going to convert these 1.25 milliseconds into proper milliseconds units. So for that, let's start. So the function that we are going to use is, the first parameter is the number of milliseconds that we want. For the minimum connection interval, I will put here 100 milliseconds. and then I will define the unit, which is unit 125 ms constant. So basically it's telling, oops, basically it's telling that our single unit of time is 1.25 milliseconds. So from this constant we are directly passing this constant and the number of milliseconds that we want. Next thing is a maximum connection interval. And the next thing is the slave delay, which is the slave latency. So for that we will just write here 0. So if you want to write more, then you can, but make sure it all follows everything, like the connection timeout, and the minimum and maximum connection interval. Everything should be aligned in the proper timing manner. Otherwise it might cause some unknown errors. And the connection timeout that I'm gonna put here is 4 seconds. For that I will put 4000 milliseconds, or we can use 2000 milliseconds. So in 2 seconds, if the device is not responding, then our connection will be terminated. And here the minimum unit for this is 10 milliseconds, and it's not in 1.25 milliseconds. Okay, the basic constants have been defined here. So now let's create a function, and this is going to be the step number 6. Now let's create a function. So for that, so the first thing is we have to create a variable error code, and for that, the next thing is we need to create the structs which are going to hold our preferred connection parameters for gap and for the security mode, because we are initializing our security mode here. We will set the device name here. We will set the preferred connection parameters here. And if you want to set the device address resolution or other stuff, we can, but right now we are not going to do that. We will see it in the later tutorials. We are going to create a simple struct which is going to hold all the values for the connection parameters. So let's name it as gapcon params. And the second one is the security mode. For that we have this struct, and let's name it as security for security SEC and mode security mode. Now we will use a special function which is going to set all the default settings as we want. So here we are just creating a simple application, so we don't need the security. So we are just going to set it into the safe mode 1, and which is open or no security. So for that, let's call this function. So here we have different modes, as you can see. Set sign no MITM. Man in the middle is MITM, and for that we have some special signed authentication, and etc. We have to do that. These procedures, as I have shown in the slides, we will see them later on in the security of BLE. Right now we are just going to see the simple basic application, so we don't need any security. So I'm gonna set it to open. So open will set all of the basic open settings, and we have to just pass it the struct that we have just created in the above line of code. Now the next thing is we have to set the device name. To set the device name, we have a special function. So for that we will use the error code check as well. So let's set the device name. And here the first parameter is basically the security mode. We will just pass it the struct in which we have saved our open security. So we will just pass it the struct address. So here the second parameter is the device name. So for that we have to first we are just typecasting as a pointer and to the device name. And the next thing is we have to pass the string length. So for that we will use a simple strlen function, and here we will just pass the device name. And now we will just check it in the app error check. Okay, the device name is set, and the security mode has been set, and now the device name has been set. So the next thing is we have to initialize the connection parameters. For that, first we will clear the memory for the gap connection parameters struct, and then we will assign them the values. So first let's clear it up. So using gap con parameters, so basically these are the connection parameters structure, and we will clear it with 0. And now we have cleared the memory for this structure, and now we are going to set the values. So let's set the values. So the first one is minimum connection interval, and we will pass it the constant minimum con interval. The second one is the maximum connection interval. The third one is a slave latency. And the fourth one is the connection timeout. Okay, now we have set it. Now we are just going to pass this struct to ppcp set function, which is basically peripheral preferred connection parameters set function, and it's going to set all these connection parameters. And our gap initialization is finished here. So for that, let's we have to check it. So we will use error code again. We will use this variable, and then we will use our function to set the ppcp. And here we will pass the address of the struct. So I'm just using an and before the struct name. And now we will use the app error check, and it's finished. So basically this is the basic code for the gap parameters initialization. Here we have seen the security modes and the name of the device and the preferred connection parameters. So we have seen everything. This is the basics of gap initialization. We will jump into more details later on. Right now we are just making a basic application. If you are directly seeing this video, please watch my previous tutorials to see everything, what's happening and how I'm creating this basic code. And if you're new to my channel, please be sure to subscribe to my channel and hit the like button if you like this video. If you have any questions, you can ask me in the comments below. Thank you very much. See you in the next video.